Hello everyone, welcome to my channel Hypermesh Basic to Advanced. So in this video we will be performing crash analysis. So before starting I would like to give a background of this channel. So in this channel I make video tutorials for Hypermesh related to FEA. So if you're new to this channel, you can consider subscribing to this channel so you don't miss out on these videos. And if you're already following but not subscribed, consider subscribing as these videos take a lot of effort to make. Thank you. So going back to the topic, what is crash analysis? So in crash analysis, we basically check how the body or subject which undergoes crash deforms and how the energy is transferred when it collides with the body more rigid than it. Okay. So basically we have two things here. We have a body or subject and we have a rigid body which is more rigid than the body or subject. Fine. So then where is this analysis mostly used? So this analysis is mostly used in automotive industries, right? To check the safety of the vehicles. Fine. So if any one of you knows about automotive industry would know there's something called NCAP testing, right? So what is NCAP testing? So NCAP testing are basically in NCAP what they do, they use the vehicles and they crash it against some rigid bodies to check how it deforms, how it behaves, and how is the energy transferred to chassis, and how is the passenger safety in that vehicle. So again, if there is NCAP testing, then why do we need this analysis, right? So NCAP testing, basically, NCAP testings are destructive testing. So what happens is, in destructive testing, when something undergoes destructive testing, it can't be salvaged, right? It's gone, it's destroyed. So same thing with vehicles. When a vehicle undergoes NCAP crash test, it undergoes a destructive testing. So what happens? The vehicle can't be used again, it can't be salvaged, and the cost of manufacturing the vehicle is gone. Fine. So what is the thing here? What is the problem here? So yes, we have to do this crash test again and again, again and again. Then the companies will incur more cost. So to save on this cost, companies basically use a cost-effective way. They perform crash analysis beforehand and they check if all values are under limits, and then they go for this NCAP crash test, right? So this helps them to save cost. Okay. So starting with our tutorial. So if you can see on my screen, I already have a mesh model. So here the subject used or the body used is a bullet. Basically, we are not using any vehicle here. This is just for demonstration. So if you want, you can use the vehicle and you can mesh it and you can just follow this tutorial and just see the results. Fine. So basically I have used a bullet here. So this bullet is meshed with 2D quad elements, right? As you can see here, quad elements. Fine. So this bullet is the subject, and if you can see there's a green structure here, right? Green plane. So this green plane is basically the rigid structure. This is the rigid wall. Okay. So we have a subject, we have a rigid wall, right? So next we have to create materials and properties, right? So I've already created material and properties. If you can see here, I've named this material crash material here. Okay, and if you can see the card image here is M2 class Johnson, right? So I'm using this basically because we are using a Radioss solver, right? So if you don't know Radioss solver is used for solving this non-linear uh, uh, analysis, right? Before this, in my videos, I've used OptiStep. So OptiStep we can use for solving, but it's mostly preferred for optimization, right? So I've already created a material and named it crash materials. So all the details, all these fields, the values in these fields, you can check it out on my blog. I've mentioned it there. Okay. So we'll create a material for the bullet, which I have already created. Then we need to create a property for the bullet. So I've already created a property that is crash property. If you click here, you can see So this is basically a shell property of this 2D elements, right? The thickness I've used here is 3 mm, and other parameters you can check out on my blog again. The link to which I'll pin in the description. Okay. So material properties are created and we'll assign it to the bullet component, right? Crash property and crash material. So we have meshed the model, we have created the material property for the model. Next. So currently the bullet is in static condition, right? So it's not moving, nothing is moving, it's in static condition. For any crash analysis, the body should be in a dynamic state, right? It should be moving. So for the body to move, we'll apply a velocity load on it, right? So for that, we can just go to, you can see tools here. You can just go to tools and you can go to boundary conditions manager. Okay, and window like this will open here on the left side, as you can see, and we'll just put the name of the load collector, whatever we wanted. We already created one, the name velocity, and the select type will be initial velocity, right? It will be INI initial velocity. Fine, and then we'll give the initial velocity along the, you can see here, the initial velocity will be along the negative z direction. You can see here, the bullet is pointing towards the negative z direction. And here we can just select the part, right? Go to components here, you can select the component and then you can apply the velocity in the direction. Fine. I've already created one if you want to see. So I've named it velocity. The part I've selected the bullet component and the velocity is in the negative z direction, if you can see here. Fine. So we have created the velocity. So just review it. Just in case you want to see. Okay, so you can see these are the velocity, right? Initial velocity of 50 meter per second. I will do initial velocity of 50 meter per second here. So this is 50,000 because it's in mm per second, right? In Hypermesh, the unit for velocity it's mm per second. That's why it's 50,000 mm per second. Okay, so it's along the negative z direction. Fine. Just close the review. Fine. So we have assigned the velocity. We have created the material and properties. Next. So next we'll need to define this rigid wall, right? So this rigid wall, for this rigid wall, you can just create a temporary node here and you can just translate it to some arbitrary distance as you wish. And then we can just right click on this white browser area, go to create, and you can go to this rigid wall here. If you can see, so what will happen? One component collector will open under rigid walls. You can name this whatever you want. Then you have to give the coordinates for this rigid wall. So we can select that temporary node for giving the coordinate for that rigid wall, and we can just assign the normal direction for this rigid wall. So the normal direction for this rigid wall will be the z direction, right? You can see here, it should point along the z direction, right? And this under Gmod ID1, we can just select the bullet component, right? So what is this Gmod ID1? This is basically the slave entity ID for this rigid wall. Fine. So just delete this. I've already created a rigid wall. You can see here. So this was the coordinate of the temporary node which was used, and normal direction is 001, that is along z axis. Fine. Gmod component is this bullet component, right? So after this, we need to create this contacts, right? So what will contacts do? Contacts will simulate how this bullet uh, deforms after crash, right? So for that, we can just go right click on this white browser area and we can go to create and we can go to contact. Okay. So it will create a part component, the groups collector, right? So as you can see here, I've already created a contact. I've named it group 1. You can name it whatever you want. Fine. So the card image for this contact will be type 7 and the Gmod ID will be both. This will be same, like it will be the subject, the bullet component, fine. The slave and master both will be this bullet component, fine. So, and the other value you can again check it out on the blog. It's given there. You can just check it out there. Otherwise, this video might become too long. So I try to keep my videos short so people don't get bored while watching the full video and just leave it. So you can just parallelly open my blog in another tab and see the video in this another tab, and you can just follow. Fine. So we have the component, the bullet component, right? We have the material assigned, we have the property assigned, we have the initial velocity assigned, right? And we have already created the content, right? So what else? So in Radioss, we just need to define one output block to get our outputs, right? So we go to result. So if you see here, I've already created output block collector. So for that, you can just again right click on this white browser area, go to create, and go to output block. You can see it here, right? Here you can go. So what we'll do in this output block is we'll select which entities output we want to see. Fine. So in that under that we'll select the bullet component, right, to see the output. Okay. And the number of variables we'll select as one, and rest everything will be default. Fine. Now all these are done from the model point of view. Fine. So can we proceed? So before proceeding, we just need to do some extra things, right? So what happens in Radioss as a solver, when the Radioss engine runs, you have to give some uh, values as to how long the engine will run, like at what duration it will take the outputs, the results, at what frequency it will take the output or results. Okay, so for that we need to define these cards. So for defining those cards, I've already defined these cards here. So I'll tell you how to define. If you just want to know, we can just go to analysis. We can go to control cards here. You can see, and you have all the cards here. Fine. So this green are what I have already defined. Fine. So I'll show you what are the values in this. So there's a card called engine animation DT, right? So the frequency for that is 80 to the power minus 5. Fine. Then engine animation element. So in this what all elements we want to see in the animation. So it's EBSP, energy, R glass, and one mysis stress. Fine. So these are the four things we are extracting. Okay. Then engine monitoring. So what is engine monitoring? Is basically when you run the Radioss engine, you want to see the progress continuously. So for that, you can just switch this on. It's basically on here. If you can see, I've kept it on. Then engine run. So how long you want the engine to run? So you can give a time here. Fine. So this is basically engine run. So it's 0.008. Okay. Then engine T file. So for this I used the value of 4 e to the power minus 5. Fine. And this engine version is basically the radio version. It's 2019. I'm currently using 2019. Fine. So this is for the engine setup, right? Not exactly setup, but just to run the engine according to your requirements. Fine. So post this, what will happen is when we are almost ready, we have the component, we have the subject, we have assigned material and properties to it, we have created the rigid wall, right? And by the way, we don't need to assign any property to this rigid wall as it's a rigid component. Fine. So after this, we have created the output block, we have given the velocity, we have given the contacts, right? And we have created the output cards, right? So after this, we'll just run the Radioss engine and see the results. For that, we can go to analysis. Okay, go to Radioss, and if you can see here, this, so we can just click on this Radioss. Okay, so what will happen? this will generate two files here. Fine. So I'll show you the files. So apparently I think I can't record my file explorer. Fine. So I'll tell you basically what happens is uh, once you just click on this Radioss, it will generate two files, right? So one will be 0000 and one will be 0001. So these two files are basically starter and engine file for the Radioss engine, right? So these files are basically exported from this Hypermesh so that we can run it in Radioss engine. Fine. So next we'll just run it in the Radioss engine and we'll see how it goes. So if you can see my screen, this is the input screen, input dialog box for this Radioss engine, right? And here we have to select the input file here. So if you can see the input file, it's 0000. Okay, fine. And then we just click on run and it will start to run. Okay, and just click on run. So if you can see the Radioss engine is running. Fine. So we'll give it some time to solve and we'll see how it performs. Fine. Okay, so the solver run was successful. So if you can see my screen, the bullet component here and the rigid wall here, right? And on the right side, I have a graph displaying this total energy, kinetic energy, and the internal energy. Right? So if you can see here, this is how the displacement look like. Okay, fine. So we can just go and check the resistors also. Okay, so basically this is how the one resistors look like. Yeah. Okay. So these areas are under high stress, as you can see here in the plot. Fine. So if we can just try to play this, as you can see it's going right. If you can see how it's going, just observe the this, we call this rectangle here, right? And I'll just play it here. So if you see, currently it's at some distance from the wall, and if I just play it, it's going and it's crashing here, and then its kinetic energy is going to zero, right? And it's basically this internal energy and its total energy, right? So if I can zoom, you can just okay, yeah. As you can see here, what it is basically, this is the kinetic energy. If you can see, this is the internal energy, and this is a total energy, right? So what happens is after it crashes, its kinetic energy goes down, total energy is going like this, and internal energy increases, right? So this is basically how you can perform a crash analysis. Fine, and you can just observe the energy changes here, right? And you can observe the stresses. Fine. So this is all for this video. So I hope you like this video. You got a basic idea of how we perform crash analysis and like how is this useful uh, in a general industry practice, right? So if you like this video, please like, share, and subscribe. Thank you for watching. See you all in my next video. Thank you.